In today's class, we'll learn about inverse Laplace transform by complete squaring. Here, in this lecture, we'll see the shifting property of inverse Laplace transform and how to simplify or how to make a complete squaring for the given denominator. And especially we'll see the example problems here as find the inverse Laplace transform of 1 upon s square minus 4s plus 8, and the second problem is find the inverse Laplace transform of s plus 2 whole divided by s square minus 4s plus 13.
Inverse Laplace transform by completing the square. So this completing the square, we needed shifting property for inverse Laplace transform. So to simplify the examples of this inverse Laplace transform of completing the square, we need one of the important property. So already we know that so we have the property Laplace transform of property that we have the property that if Laplace transform of f of t is equal to f dash of s, then we can write the property. See, already we have done this. E raised to at into f of t can be written as what here? F dash of s minus a. This already we have seen in Laplace transform. So I want to reverse this one. So in inverse Laplace transform, what happened here? So we'll reverse it. So L you shift to the right hand side. So therefore I can say that, so here in inverse Laplace transform, so L you shift to the left hand side all. If here L if you shift to the right hand side, it will become out here L inverse of f dash of s is equal to f of t, then L inverse of f dash of s minus a will become out here e raised to at into f of t. We need to remember this property while solving the examples of inverse Laplace transform. Okay, so if L inverse Laplace of f dash of s is equal to f of t, this is the definition, then L inverse of f dash of s minus a is nothing but e raised to t. This e raised to at is not, if minus a s minus a, it will become e raised to at. If s plus a, it will become e raised to minus at. So you have to remember here, and for this we need to apply what here, one of the important property of this Laplace transform and inverse Laplace transform example. So you just observe here. So so these examples means we are using here for completing the square. So the given thing, if it is not completing the square, at that time we'll use this concept and we'll apply the inverse Laplace transform, then we'll apply the final conclusion here. So we'll see the examples based on this completing the square using inverse Laplace transform. Find the inverse Laplace transform of 1 upon s square minus 4s plus 8. See, you just see the question here. So if you see the question, it will not fit to our any of the standard form of inverse Laplace transform. So as we know, we have one of important formulas for inverse Laplace transform, which one we have discussed in the previous lectures. So I will once again will glance those formulas here. So inverse Laplace transform of 1 upon s is 1. Next, inverse Laplace transform of 1 upon s minus a is nothing but e raised to at, and inverse Laplace transform of, if it is 1 upon s plus a, it will become e raised to minus at. Similarly, next one, inverse Laplace transform of s upon s square plus a square is nothing but cos at. Inverse Laplace transform of s upon s square minus a square will become cos hyperbolic of at. Next is inverse Laplace transform of 1 upon s square plus a square is sin at upon a. Then inverse Laplace transform of 1 upon s square minus a square will become out here sin hyperbolic of at upon a. Then inverse Laplace transform of 1 upon s raised to n plus 1 will be t raised to n divided by n factorial. This formula we are applying when n is what here positive integer. And one more formula what we have here. So L inverse of 1 upon s raised to n plus 1 will apply t raised to n upon gamma of n plus 1 when n is less than minus 1, or I can say that it is in the form of p by q form. So if it is in a fraction, n value is in fraction, then we'll use this. So with the help of this small list of formulas, we'll see what is the actual results of the given question. So what given question is there, it is not of the form or here any of these formulas, so we cannot apply directly. So what we'll do here, first we'll see how we'll make this denominator so that we can fit to the any of the standard formula. For this we'll write symbolically. So therefore given thing, we need to find inverse Laplace transform of 1 upon s square minus 4s plus 8. So but denominator is not able to fit in any of the standard formulas of this inverse Laplace transform. So therefore, so what I will do here, this 1 upon s square minus 4s plus 8 I will take first, will simplify, then we'll apply inverse Laplace. So for this, so we call this is one of the heading what we are doing the problem, that is nothing but complete. So we have to make a complete square this denominator. So how to make it? So just we'll see here. So as we know here, so we know the formula a plus b whole square is nothing but a square plus 2ab plus b square. And similarly we have the formula a minus b whole square is nothing but a square minus 2ab minus plus b square. So this is nothing but we can, if we bring a square plus 2ab plus b square, so we can write a plus b whole square, and if this expression will bring in the form of a square minus 2ab plus b square, we can write this a minus b whole square. So this is nothing but completing the square of the given function here. So therefore once again 1 upon s square minus 4s plus 8. So here this 1 upon s square I will keep as it is, minus as it is, this 4s I will write 2 into s into 2. Okay, so this 4s I will write 2 into s into 2. 2 2s of 4 into s will get back 4s. So this I will write a square minus 2ab. So a value is s here, b value what we can consider here, it is nothing but 2. So b, so a square minus 2ab, next what we needed plus b square. So for this arrangement what I will do here, So this, you consider that this is the b value here. So we'll add 2 square and we'll subtract 2 square. So s square minus 2 2s of 4s. So this 2 square is 4. So 2 square minus 2 square cancels, we'll get back our previous, and this plus 8 as it is. So just this is a manipulation to make a complete squaring, then applying the inverse Laplace. So which is nothing but 1 upon, just see here. So this step completely, what underlined I have made, s square minus 2s into 2 plus 2 square, that is a square minus 2ab plus b square is nothing but what here, a minus b whole square. So I will write this one as s minus 2 whole square. This minus 2 square is nothing but minus 4 plus 8 as it is. On simplification, 1 divided by s minus 2 whole square will keep as it is. Minus 4 plus 8 is nothing but how much here? Plus 4. So therefore, now we'll apply inverse Laplace transform for this. So therefore, take a inverse Laplace on both sides. So L inverse of 1 upon s square minus 4s plus 8, which one we have made complete squaring, that is L inverse of what here, 1 upon s minus 2 square plus 4. So 4 I will write what here, 2 square. 4 I will write 2 square here. Now here this is this 2 is nothing but the value of a. So we know that just now we have done the shifting property. A Laplace inverse of f of s minus a is nothing but e raised to at into f of t. So here what I will do here, so here the value of a is 2, and so value of a is 2, and this s minus 2 changes to s. So remember this. So value of a is 2 and s minus 2 changes to s. So here, so therefore what happens here, it is nothing but e raised to at I want to execute. The value of a is 2. So e raised to 2t. So the remaining s changes to what here? S minus 2 changes to s means what here? Laplace inverse of 1 upon s minus 2 changes to s means s square plus 2 square. So e raised to 2t. Then now as per the formula, so inverse Laplace of 1 upon s square plus 2 square. So I will just recall. So inverse Laplace of 1 upon s square plus a square is nothing but sine of at upon a. So this a value is nothing but whatever here plus a square is there, that is the value of a. So that will take it now. So therefore, so inverse Laplace of 1 upon s square plus 2 square is nothing but sine of 2t upon 2. So this is nothing but our required solution. So sine of 2t upon 2. So therefore inverse Laplace transform of 1 upon s square minus 4s plus 8 is nothing but, this is the solution. So next example, find the inverse Laplace transform of s plus 2 divided by s square minus 4s plus 13. So solution. So denominator also is not in a proper form. So we need to find inverse Laplace transform of s plus 2 divided by s square minus 4s plus 30. So we'll simplify this first again. So again, denominator is not of any of the standard form, so we'll make arrangement for this, then we'll apply the inverse Laplace transform. So now, so inverse Laplace transform of s plus 2 divided by s square minus 4s plus 30, which is nothing but inverse Laplace transform of s plus 2 divided by, so numerator will keep as it is, denominator will again make a perfect square, s square minus this 4s will write what here, 2 into s into 2, that is a square minus 2ab. So again we got 2 here, so therefore plus 2 square minus 2 square and this plus 13 as it is. Hope you got the point how to make a complete squaring. So inverse Laplace of s plus 2 divided by, so this step s square minus 2as into b plus b square, this is nothing but s minus 2 whole square and minus 2 square is minus 4 plus 30, which is nothing but L inverse of s plus 2 divided by s minus 2 whole square minus 4 plus 30 plus 9, so which is nothing but L inverse of s plus 2 divided by s minus 2 square plus 9, we can write 3 square, but denominator we have made a complete squaring, but numerator also we need to simplify. So here we have s plus 2 and here we have s minus 2, so here also we need one term s minus 2. So what we'll do here for that, denominator will keep as it is, that is s minus 2 whole square plus 3 square, numerator I will make it as s plus 2 then minus 2. So what I will do here, I will add minus 2 and plus 2. So minus 2 plus 2 is again 0, then s plus 2 will get back. So but while making this, I will rearrange like that, that is L inverse of this s and minus 2 I will take one side. So s minus 2 and plus 2 and plus 2 will become plus 4. And I will make bracket for this, s minus 2 square plus 3 square, so which is nothing but L inverse of, so here 2 term divided by 1 term this completely, so therefore s minus 2 divided by s minus 2 whole square plus 3 square 1 term plus 4 divided by s minus 2 square plus 3 square. Okay, if you take the LCM we'll get back, and if you simplify this we'll get again s plus 2 only. Okay, just this is a manipulation we needed. So therefore we'll separate it. So inverse Laplace of s minus 2 divided by s minus 2 whole square plus 3 square plus inverse Laplace of 4 divided by s minus 2 square plus 3 square. So now finally, so here, so we'll apply the shifting property. So to apply shifting property, so here I will say that the value of a is what here, 2, and s minus 2 changes to s. So therefore what happens in the above step, it will become, if you apply shifting property, that is e raised to value of 80, e raised to 80, a value is 2, so therefore 2t into inverse Laplace of s minus 2 changes to s minus 2 changes to s, so s divided by, so s minus 2 changes to s, so s square plus 3 square plus inverse Laplace of, so this 4 I will keep outside, this 4 I will take outside, so it will become 1 divided by s minus 2 changes to s, that is s square plus 3 square. You can write directly also, or else this step is uh, easy to understand. So therefore e raised to 2t, actually here also we need into e raised to 2t, so this is a separate term. So here also we have s minus 2 means shifting property will apply here also. So therefore e raised to 2t into, so this is nothing but s divided by s square plus a square, inverse Laplace. So s is coming means cos of, so value of here it nothing but how much here, 3t, and plus 4 times e raised to 2t into, this is nothing but 1 upon s square plus a square form, that is nothing but sine of 3t upon 3. So therefore, so in this way this is nothing but a solution of inverse Laplace transform of s plus 2 divided by s square minus 4s plus 30. So in this way you need to simplify the problems based on inverse Laplace transform by completing the square.